All right, guys, so let's get started with another lesson here. So we are going to be doing warm-up for lesson 82, so solving multi-step compound inequalities. So let's go ahead and get started. If you're wondering what page we're on, we are on page 538. So warm-up numbers 1 through 5. So go ahead and give those a try. Pause your video so you can do them on your own because I'm about to do them. I'll give you the answers here in just a second. So number one, we have our vocab term. So a blank is made up of two inequalities combined with the word and, or. So the answer is right in your introduction of the lesson. It's going to be a compound inequality. Okay. Now, number two, we have, so solve each inequality. So we have 8x is greater than 6x minus 12. Okay, so let's give that one a try. Change my color here. So for this one, this is pretty much the same thing we were doing in our last lesson, so lesson 81. So we're going to subtract by 6x, both sides. We're combining our like terms. So we are going to be left with 2x is greater than negative 12. Divide by 2 to both sides. What are we left with? We are left with, so the x or the 2's cancel out there, we're left with x is greater than negative 6. X is greater than negative 6. Okay, so that's number 2. I'm going to erase all that now so I can write down number 3. If you didn't get all that written down, just go ahead and rewind and then pause so you can get that written down. So number 3 here. So we have -1, -1 minus, we got a lot of negative signs here, minus -7, which is less than or equal to 3 times y minus 6. Okay, so what are we going to do? We're going to combine our like terms. So 1 minus -7. So 1, and then our minus a negative number that's going to turn into a positive. So plus 7. Okay, so 1 plus 7, that's going to be positive 6. Before I get too ahead of myself, so 1 plus 7 is less than or equal to, so 3 times y, 3y, and then 3 times -6, we got -18. So we have 6 is less than or equal to 3y minus 18. So I'm going to add 18 to both sides, so add my like terms. And by 18 to both sides, I am going to end up getting 24, so 6 plus 18, add another, so that's going to be 24 there, which is less than or equal to 3y, and then divide by 3 to both sides. Divide by 3 to both sides, we get y is less than or equal to 8. Y is less than or equal to 8. That would be our answer there. Okay, so go ahead and pause if you need to so you can get all that written down. And if you have questions on it, of course you can email me or just watch the video over again through that section. Okay, so now we have number 4. Now we have number 4. So what do we have here? We have x minus 2 we have x minus 2 is less than negative 7. Now we're throwing in a or here, or 2x is greater than or equal to 11. Okay, so essentially what you're going to be doing here is solving both inequalities. Be solving. So let's start out with x minus 2, which is less than negative 7. Okay, I'm going to get my different color here. Let's use red. So add 2 to both sides. Add my like terms. I'm left with x. So those are canceled out. X is less than negative 5. Or, so for this one, we have divide by 2 to both sides. And I am left with x is greater than or equal to 5.5. So if you're wondering how I got 5.5, so what is 2 times 5? 10. And then half of 1 is going to be a half. So that's how I got my 5.5 there. And if I wanted to draw this out as on my little graph line here, I'll show you that real quick. So I would have a negative 5 down on this end, a bunch of dashes, negative 4, 3, 2, 1. Here's my 0. And then 1, 2, 3, 4, 5, 6. So somewhere in there is going to be my 5.5. So use another color here. Use my blue. So for x is less than negative 5, it's going to be an open circle. And then for 5.5, it's going to be a closed circle. Closed circle. Okay. And then when we draw our lines, so x is less than negative 5. So less than negative 5, our arrow is going to point in the left direction because it's all the values that are less than negative 5, not greater than, because if we look at negative 4, which is right next to it, negative 4 is greater than negative 5. So we want all the values that are greater or less than negative 5. So negative 6, negative 7, negative 8, and so on. And then for the 5.5, over here, my filled in dot, we have x is greater than or equal to 5.5. So that's also going to be in the opposite direction. So that's going to be a little bit, that's an introduction of what we're going to be doing here with our new concepts. So go ahead and do number 5 on your own, and I am going to move on to example number 1. Example number 1. All right, guys, so we have a similar, so our example 1 here is very, very similar to that number 4 warm-up problem, like I showed you. So what we're going to do is we're going to do both this 4x minus 7, which is less than 3 inequality. Then we're also going to do this separate inequality, 2x minus 19 is greater than negative 7. So when we do those, we are going to then graph them on our number line, like I showed you in warm-up problem number 4, okay? So let's get started here. So add our like terms like we've been doing over and over again. So add 7 to both sides. We are left with 4x is less than 10. Divide by 4 to both sides. So I'm going to show you how I get my answer here. So 10 divided by 4. I know some of you can just do this in your head. So 4 goes into 1, 0 times. 4 goes into 10, 2 times. So that's going to be 4 times 2 is going to be 8. We're left with 2 here. Add our decimal. Bring down our 0. So 4 goes into 20. How many times? 5 times. We're left with a remainder of 0. Okay, so 2.5. So x is less than 2.5. Okay, so I'm going to erase all that division over there that I just did. So I have some room for my other inequality. So x is less than 2.5, or also have, so add my like terms. So negative 19, add to both sides. Add to both sides. 19s cancel out. We're left with 2x is greater than, so negative 7 plus 19. I'm going to have, essentially, it's just 19 minus 7, which is going to give us 12. Divide by 2 to both sides of our inequality here. 2's cancel out. I'm left with 2 is greater than 6. And that is what they also have in the book. So now I'm going to graph that on my handy dandy number line here. So I need all my values to be from 2.5 to 6. So I'm going to start at 2, and I'm going to go all the way to 6. So 2, 3, 4, 5, and 6. So I'm going to plot one of my points. Use blue again. So 2.5, so that's right in between, and it's an open circle. So x is less than 2.5. So it's going to be all the values on the left side. So if I were to plug in a 2 for this x, is 2 less than 2.5? Yes, it is. If I were to plug in a 1 for that x, is 1 less than 2.5? Yes, it is. So it's all those values on the left side of our number line. That's how you would check for that. And then here in our other equation, we have, or inequality, we have x is greater than 6. So pen back out. So at our value 6, our inequality is going to be an open circle because it does not include 6. So x is greater than 6. All right, so let's try out a value here. So for x, let's try 5. Is 5 greater than 6? Nope. So let's try out the number 7. Is 7 greater than 6? Yes, it is. So it's looking like our arrow is going to go that way. So what if I tried 8 for our x value? Because that should work, right? Is 8 greater than 6? Yeah. And then you could do that for every value all the way up to the highest number you could think of. Okay, so if you have any questions on that, again, email me. Go ahead and do letter B on your own for example 1. The only difference with that one is you're going to have everything inside of your number line. So it's going to look something like this. So let me draw my number line back out and show you what it's going to look like. So my number line, I'm going to have it here, and it's going to be all my values in between. So it's going to be everything inside. So this is where it's going to look like Baymax here. So I have, let's put a 0 right here, a 1 here, and a 2 right here. So it's going to be everything in between, all numbers in between 0 and 2. So all numbers in between 0 and 2. So that's going to be the type of problem that you're doing on letter B. If you have any questions with that one, email me. They give you the step-by-step pretty well there in the book. So if you have any questions, let me know and I can help you with that. So let's move on to example 2 once you are done with letter B. So pause your video and get that going. Okay guys, so when we are looking at example 2 here, letter A and B, letter A, there's something a little bit different about it. We have, so right here it says negative 15 is less than or equal to 3 times 2x minus 1, which is less than or equal to 39. So what we're doing here is whatever we do to this 15, we're also going to do to this 39. So what I mean by that is we have two different equalities here, all combined into one. So let me show you what I'm talking about. So I have negative 15 is less than or equal to 3 times 2x minus 1, or I also have 3 times 2x minus 1 is less than or equal to 30. No, red. Less than or equal to 39. There we go. I had to write that one with my mouse for some reason. Okay, so that's what this is saying. So you can write it out like this, or you can do it the way that they're doing it in the book. It's a little bit more confusing that way, but if that way works for you, great. So you can look at it in the book that way and try it that way if you'd like, or you can try it this way that I'm going to show you right here. So let's try our first inequality first, because now this is something that we have done before in example 1. So we have negative 15 is less than or equal to, so let's do seed here. So 3 times 2x, 6x, 3 times negative 1, negative 3. Add 3 to both sides. We're going to have negative 12 is less than or equal to 6x. Divide by 6 to both sides. We are left with negative 2 is less than or equal to 6, because our 6's canceled out there, and then we're just left with negative 12 divided by 6. So that'll give us negative 2. Now let's do our other inequality. So 3 times 2x, again, 6x, it's going to be the exact same thing that we did over on that first inequality. And then 3 times negative 1, negative 3 is less than or equal to 39. Okay, so let's add 3 to both sides. And I'm going to be left with 6x is less than or equal to 42. Divide by 6 to both sides. You guys can see where this is going. I am left with x is less than or equal to 7. 42 divided by 6 is going to be 7. So the way they wrote it out in their answer is like this. So negative 2 is less than or equal to x, which is less than or equal to 7. So that's the same exact answer that we just got, except they wrote it in one single inequality. So how we can also write it, which is the way we just did, negative 2 is less than or equal to x, or x is less than or equal to 7. Okay, so this would be like one of our examples where we have our number line that looks like Baymax. So -2 all the way to 7. So we have our dots here, and it's going to be everything in between. Everything in between there. See, looks like Baymax. We have our eyes here, and then we have our line for Baymax's face, for those of you who know what I'm talking about. Okay, so not too bad there. Go ahead and give letter B a try. It is the exact same process that we just did. So go ahead and give that a try. And then example 3 is an application problem. So that's all I have for you for this lesson. So do letter B and example 3 on your own, and go ahead and get started on your homework after that on page 540. All right, guys, keep having a good break. Stay safe. Bye.